Fine. So we have studied stack. We have seen what is stack, then what's an ADT for stack, and then the implementation of stack, and then its applications. Now we'll be talking about the next data structure, which is called as queue. Okay. So what was stack? This is what we have studied about the stack. Okay. A stack is a linear data structure in which addition and deletion of data are done from a same end. Okay, and this end is often referred as top of a stack. This is also called a LIFO style of processing, last in first out, because what happens that you have one data structure, and that data structure has only one open end. So the another end is closed, and there is one open end, and from this one open end only you can insert or delete the data. So when you insert the data from a single open end, whatever you are inserting last, that will be coming out first. Whatever you are inserting last, that will come out first. So example is a stack of plates or stack of books. So when you keep the plates one after another, or when you keep the books one after another, so whichever plate is on the top, or whichever book is on the top, that plate or that book is the first thing which will come out. So that's why it is called last in, first out, LIFO structure. Okay. Then when we talk about queue, a queue is a data structure in which both the ends are open. So you just imagine a pipe. Okay. So take an example of pipe. So if you have a pipe, the pipe has two ends. So if one end of the pipe is closed, so there is only one end from where the things can move into the pipe and can come out of a pipe. So such a pipe resembles stack. I repeat, such a pipe which has only one open end and another end is closed. So such a pipe resembles stack, because there is only one open end from where the things can move into it and can come out of it. When you say queue, so it can be something like a pipe where both the ends are open. The two ends are open. Okay. So a pipe in which the two ends are open. So you can insert the thing from one end, and then that thing comes out from another end. So if you have this kind of setup, if you have this kind of structure in which the insertion of data is done from one end and deletion of data is done from another end, so in this case, can you tell me that the element which is inserted first will be deleted first, or the element which is inserted last will be deleted first? Please answer me. The element which is inserted first, that element will be deleted first, or the element which is inserted last, that element will be deleted first in case of queue when both the ends are open? Some are saying first, some are saying last. Now, if you have a pipe where both the ends are open, and when an element is inserted from one end and second end is open, so that element moves in, so that element will be the element which is going to be deleted first. I mean to say, the element which is inserted first, that element would be deleted first. The element which is inserted last, that element would be deleted last. The element which is inserted second, it would be deleted second. The element which is inserted third, that would be deleted third last. Okay, something like that. A queue is nothing but your regular queue. What does it mean? That when you go to a railway station, so to get a ticket, you have a queue. So how that queue is processed? When you are in the queue, you keep on moving forward. And when your number comes, that time you are served, or that time you are removed from the queue. Okay, you are given a ticket and you are removed from the queue. So in queue, you can easily see that the person who is entering first, that person would be served first and that person will be removed first. The person who is at the end of a queue, that person is the person who would be served last, and that person will be removed last. Okay. So your queue is nothing but first in, first out data structure. I repeat, first in, first out data structure. Whichever is inserted first, that will be deleted first. Whichever is inserted first, whichever data element is inserted first, that element would be deleted first. Okay, that is called your queue. So if I reframe this definition of stack into a definition of queue, so what does it become? I just copy this. We want to reframe that. And here I want to define a queue. So what is queue? A queue is a linear data structure in which addition is done from one end and deletion of data is done from another end. So it means that there are two ends in a queue. From one end you are going to insert the data, and from another end you are going to delete or remove the data. Okay. The end from where data is inserted is referred to as rear of a queue, or you can say rear end. So from the rear of a queue, a data element is going to get inserted. There are two ends. One end is called the rear end, from where the data is going to get inserted into the queue. And second, the end from where data is deleted is referred as front of a queue, or the front end. Okay. So we are going to insert the data into the queue from the rear end, and we are going to delete the data from the front end. Okay. The insertion of the data would be done from the rear end, and the deletion of the data would be done from the front end. There are two ends in a queue. Queue follows which structure? Queue follows first in, first out, FIFO structure. Queue follows FIFO structure, first in, first out. Stack follows LIFO, last in, first out, and queue follows first in, first out, FIFO structure. Okay, that's the difference. And when you say first in, first out, so it is but obvious, it is but natural that if something is entering first, and if that something is going to be deleted first or removed first, so definitely there are going to be two ends. From one end the data would be inserted, and from another end the data would be deleted. अगर एक ही end open होगा, so it is nothing but a stack from where the data is inserted and data is removed. But in this case you have both the ends open. So from one end the data is inserted, and from another end the data is removed. Okay. So whatever is inserted first, that will be removed first. First in, first out. And you are going to have two ends, rear end and front end. Rear end is the end from where the data is going to get inserted, and front end is the end from where the data is going to get removed or deleted. Okay. So that is the definition of queue. I repeat, a queue is a linear data structure in which insertion is done from one end and deletion is done from another end. The end from where the insertion is done is called the rear end, and the end from where the deletion is done is called the front end. And Q follows first in first out structure, or first in FIFO structure, or first in first out structure. Then a QADT. What was the ADT of stack? What do you mean by ADT? What is an ADT? Unmute your mic and say me an answer. Yes, please.
Abstract data type.
Yes, perfect, perfect. Full form of ADT, abstract data type. But I am asking you the definition or the meaning of ADT. What is an ADT? When I am asking what is an ADT, I do not mean to ask the full form of ADT. I mean to ask you what do you mean by कि आपके हिसाब से ADT की क्या understanding है? What is the concept of ADT? Yes, come on first. Abstract data type. What is an abstract data type? Data plus operations. एक छोटा सा आंसर आया, data plus operations. Yes, that's a good answer. But you need to clarify on that. Data plus operations अगर आप बोलेंगे तो वो सिर्फ ADT नहीं कहलाता. Okay, वो क्लास के लिए भी वो डेफिनेशन हो सकता है, data plus operation. That's what your class. In Java or in any object-oriented programming language, a class is an encapsulation, right? Encapsulation of data and the operations or the method that can be performed on this data. So ये सबको हम मिला के क्या बनाते class. But what do you mean by ADT? So you need to say clearly an ADT is a mathematical or a logical model, or it is a blueprint, or it is a specification. Okay? एक स्पेसिफिकेशन है. किस चीज का स्पेसिफिकेशन है? स्पेसिफिकेशन अबाउट द डेटा एंड द ऑपरेशन दैट कैन बी परफॉर्म्ड ऑन दैट डेटा. इफ यू सिंपली से डेटा प्लस ऑपरेशंस, यस फाइन, लेकिन उसमें दो चीजें आ जाती है बेटा. एक तो है स्पेसिफिकेशन ऑफ डेटा प्लस ऑपरेशंस, और दूसरा है इम्प्लीमेंटेशन ऑफ डेटा प्लस ऑपरेशंस. सो एडीटी इज ऑलवेज अबाउट स्पेसिफिकेशन. इट इज एब्स्ट्रैक्ट, इट इज हिडन, it is not implemented, it is not concrete. Okay, so it is abstract, it is hidden, it is not concrete. Fine. So you need to specify that it is a specification, it is just a blueprint. It is something like you are writing on paper that this would be my data and this would be the operation that can be performed on this data. So this becomes an ADT. When you implement that ADT in any programming language, it becomes a data type. Okay, so whatever specification you have, whatever logical model you have, whatever mathematical model you have about the data and the operations, so that model, that specification is called an abstract data type. It's called what? An abstract data type. Okay, what was the abstract data type of stack? A finite sequence of elements of any particular type. डेटा में क्या लिखा था हमने? A finite sequence of elements of any particular type, because you can store integer into stack, you can store float into stack, you can store character into stack, you can store strings into stack, you can store students information, you can store books information, you can store vehicle information. Okay, so anything you can store into the stack. That's why we had the word particular type, a finite sequence of elements of any particular type. Okay, that become the data of a stack. And then the operations: initializing a stack, checking whether the stack is empty or not, full or not, push operation, pop operation, peek operation. So these are the operations. इन सब का जब स्पेसिफिकेशन हमने कंबाइन किया, so we came out with the stack ADT. Likewise, we need to think for QADT. What is a QADT or an ADT for the queue? Now queue is also a linear data structure, just like your stack. What is the basic difference between stack and queue? A stack has only one end and your queue has two ends. Okay, that's a very basic difference. और इसी difference के ऊपर सब differences आ जाते हैं. But if you talk about data, so you could store any kind of data in stack, likewise, exactly likewise, you can store any kind of data in your queue also. You can store any kind of data in your queue also. Okay, so your queue can store integer data, your queue can store float data, your queue can store string data, your queue can store data of students, data of vehicle, data of books, data of program, data of process, and so on. Okay, let me give you one example of queue, a very technical example of queue. Whenever you have any shared resource, and when multiple things are sharing that resource, or multiple users are sharing that single resource, okay, so whatever request is being given by that by those users to the shared resource, the shared resource will be making use of a queue to complete the request of all those users. Take an example. When you move to a railway station, to a ticket counter to get a ticket, so that single person who is issuing a ticket in for that queue, एक क्यू के लिए जो अंदर काउंटर पे जो एक सिंगल पर्सन बैठा है, that single person is a single person. So that single person becomes a shared resource for those many people, those who are standing in the queue. Okay, so how this shared resource is getting used by all the users? What is the service that shared resource is providing? The shared resource is giving you a ticket, railway ticket. Okay, so that is the service. How that service is provided to all the users? A users comes in a queue, one by one. Whoever is at the front end, that person will be served first by that serviceman by giving a ticket, by issuing a ticket. That person will be removed. The next person would come forward. That person would be served, removed. Next person would come forward. That person would be served, removed, and so on. So this is a simple example of queue. If you take on the example into a technical setup, for example, you are sitting in a lab, and in a lab, you have one printer, and that printer is shared by all the machines, by all the students. Okay. So now when multiple users, multiple students are giving a print job, all the students want a printout of the programs, and there is a single printer which is shared by all the machines. So that single printer is a shared resource now, and we all students, those who want to make use of that printer to give a print of a program or the experiment, are the users who are going to use that single resource, a shared resource. Whenever any student gives a print command from different machines, all those print command becomes a element into the queue. The printer would maintain a queue which is called a print jobs queue. I repeat, a printer would maintain a queue, and that queue would be called as a print jobs queue, and into that queue it will maintain every student's print request. So whichever student has sent the print command first, that student will come at the front of queue. Next student would come at the second position. Next student would come at the third position, and so on. And accordingly, the printer will print out. So it will not happen that one page or half page of your print got printed and half page of some other user got printed. It never happens. The first print is completely done, and then only it moves to the second print. It does the printing of the second job, then it moves to the third job, it does the printing of the third job, and so on. So this way it completes all the jobs. And this is a simple setup of a queue. So whoever is sending the first print request is sending the first print command, that would be printed first, and likewise the second would be printed second, third would be printed third, and so on. Okay. Now coming back to the QADT. So as we have seen that in a queue you can store anything. So data part becomes what? A finite sequence of element of any particular type, just like your stack. So जैसा stack में था, let me copy that part itself. QADT. Data is a finite sequence. It is a finite sequence of elements of any particular type, which can be implemented by using arrays, or which can be implemented by using linked list. Then the operations. What could be the operation? The way we used to initialize a stack, the same way we can initialize a queue. So initialize a queue becomes one operation. Check whether the stack is empty or not. Likewise, you can check whether the queue is empty or not. Exactly. Check whether the stack is full or not. Likewise, you can check whether the queue is full or not. Insert at the top of stack if the stack is not full. This operation is called push. Insert from the which end? From the rear end if the queue is not full. This operation is called insert. You can simply call it insert. Then delete an element from the front end of queue, or from the front of queue. Obviously, if the queue is not empty. This operation is called delete or remove. Specifically, the names are not fixed for queue. You can call it delete or you can call it remove. Then retrieve from the top. This kind of operation we do not have in queue. So these are the operations that can be performed on queue. Apart from this operation, the common operation is displaying the content of a queue. The way we had for stack, displaying the content of stack, the same way we can display the contents of a queue. Now the implementation part, a queue can be implemented either by arrays or by linked list. So first we will be seeing the array implementation of queue. Now whether the ADT is clear, it is simple. QADT, data part is what? A finite sequence of elements of any particular type. And then in the operations, you have again the same kind of operation, initializing a queue, checking whether the queue is empty or not, checking whether the queue is full or not, then inserting from the rear end of a queue. This operation is called insert. Then deleting from the front end of a queue. This operation is called delete, or it can also be called as remove. So these are the operations that can be performed on a queue. Then I said you that a queue can be implemented either by arrays or by linked list. So now we'll be seeing how to implement a queue using arrays. Okay, let me get that program. This is session 13. Implementation of queue using arrays. And into this, Let me have this also. So you are having your theory part also here. So the implementation of stack, sorry, queue can be done either by making use of arrays or by making use of linked list. So we'll be starting with array implementation, how to implement a stack using arrays. So as we did for stack, we will try to go in the same manner, and we'll try to make our program as general as possible and as modular as possible. Okay, two important things. Whenever you are writing a program, you need to make it general, you need to make it modular. So we'll be making use of a structure. Now, if you visualize the structure, if you recollect the structure for stack, so what we had into the stack, we had two things. We were implementing it using arrays. So first thing was the array to store the data into that structure. And second thing was stack having one end, which is called as top, which always maintains the information of the topmost element. Okay. So these two things we had into a structure for the stack, an array and then a top variable. Okay. Now, when we talk about a queue, so in queue also, you are going to maintain a data or store the data using arrays in this implementation. So definitely we are going to have one array into our structure for the queue, and then your queue has two ends, not one end. It has two ends, one end from where the data is inserted and one end from where the data is deleted. So the end from where the data is inserted is called the rear end, and the end from where the data is deleted is called the front end. So it means that in your structure for the queue, you need to maintain or you need to have array for storing the data, and then rear variable, and then front variable. Rear and front variable would be indices, I mean index, into the array. Rear would be pointing to the last element of the queue, and front would be pointing to the first element of the queue, if the queue has got data elements. If the queue does not have any data element, if the queue is empty, then accordingly we need to set the values of rear and front. Okay. So in our structure for the queue, if you see this, what do we have? We have one array. Now we are taking it as integer type, but depending upon the type of data you are going to store into the queue, you can change this. If you are storing float type of data, then make this array of float type. If you are storing a strings into this data, into this queue, then make this array array of pointer to character, array of pointer to character. Okay. So likewise, depending upon the data which you are storing into a queue, the type of this array would change. Fine. The next is two variables. One is front and one is rear. Both are of type int. Why both are of type int? Because they will be storing the index values. Rear will be storing the index value of the last element. Front would be storing the index value of the front element. Okay. If the queue has got the elements. If the queue does not have any element, if the queue is empty, then these two variables would be having a value. What value they will be having? Yes. What value they will be having? Front and rear -1. Good. So front and rear would be -1 if my queue is empty. Just like your stack. Whenever the stack is empty, top is -1, because -1 cannot be an index value in C programming language. Okay. So since -1 cannot be an index value, it means that the structure is empty. Now whether that structure is stack or queue, that doesn't matter. if this structure is implemented using array, and if the variable which is pointing to an element into a structure, if that variable is having a value -1, it means that the structure is empty. It is as simple as that. So now we can see here that into our structure Q, we have this many things: an array, and then two variable for storing the indices. Then the next is the initialize function. In the initialize function for stack, what we pass to it? We pass we passed an address of a stack. So the argument of a function becomes pointer to stack. Likewise, exactly in the same way, to the initialize function of Q, we will be passing the address of a queue which we want to initialize. Now, since we are passing an address of a queue, so there in a function, the argument should be a pointer to the structure queue. So that's why we have this pointer to structure queue. So the way we had pointer to structure stack in case of a stack program, in the same way here we have a pointer to queue. Okay, and then inside that function for stack, what we have written? S arrow operator top equals to -1. Now in this case, for the queue, our pointer name is Q, so we will be writing Q arrow operator rear equals to -1, and then Q arrow operator front equals to -1. Or you can make them in the single statement, Q of rear equals to Q of front equals to -1. And that's what we are doing over here. Okay, this is as good as writing A equals to B equals to 1. So both the variables A and B would be initialized to 1. Likewise, here also we are writing Q of front equals to Q of rear equals to -1. So it means that the front and rear variables associated with the pointer Q would be set to a value -1. That is the initialize function. And the way we have written the function for the stack, same way we would try to write for Q, so that there would be minimum differences. And once you understand a program for stack, you are in a better position to easily understand the program for Q. That's why we are keeping the things same. Even the functions names are also kept same. Okay. So then the next function is full. The same way we are implementing. There also what we passed in a stack, we passed the address of a stack, and for that we needed a pointer to the structure stack in the function. Exactly in the same way, to a is full, to is empty function in a queue implementation, we are passing the address of a queue, and since we are passing the address of a queue, what we need inside the function? Pointer to a queue. So we are taking a pointer over here, okay, and then inside the function a ternary operator. Acha. For the stack, when we wanted to test whether the stack is empty or not, the condition was what? Top equals to -1. If my top of a stack is -1, it means that my stack is empty. What was the full condition? Top equals to max -1. If the value of top is max -1, it means that I cannot store any more element beyond this because my array is full. So since my array is full, I said my stack is full or stack overflows. Exactly in the same way, you need to visualize for Q. The only point is that a queue has two ends. One end is called your rear end and one end is called your front end. From your rear end, the data would be inserted, and from your front end, the data would be deleted. Okay. So if I want to say that my queue is empty, so what would be the condition for an empty queue? What would be the condition for an empty queue? Yes. If any of the indices is -1. If my rear is -1 or my front is -1, I can safely say that my queue is empty. Okay. So if you see the empty condition is what? Either your front is -1 or your rear is -1. In any of the case, your queue is empty. What about a queue full condition? When can you say that the queue is full? Yes, come on. Yes, good. Very good. If, since the insertion is done from the rear end, see, there is nothing in your queue is empty. So your rear end and your front end, both are same. Both are -1. Your queue is empty. The moment you insert the first element from the rear end, you make the value of rear equals to 0. Then you insert an element and you make your front also equals to 0, because there is only one element, which is the first element and which is also the last element. So rear is also having a value of 0 and front is also having a value of 0, because the first element is stored at the index value 0 in your array. Okay. The moment you want to store the next element, second element, you will be incrementing the value of rear by 1. So rear would become 1 and you will insert an element into this position. So now rear is pointing to 1, front is pointing to 0. There are two elements in my queue. Likewise, if I want to insert one more element, insertion is always done from the rear end. So I would be incrementing the rear index by 1. So rear would become 2, because rear was 1. Rear would become 2. At the index value 2, we will insert a new element, and now the rear is pointing to this new element or the last element, front is still pointing to the first element. Okay. This way we'll keep on inserting the elements. How? By incrementing the value of rear by 1 and then inserting a new element at that position. So at every insertion, I am incrementing the value of rear. So when I say my queue is full, so basically I need to check my rear index. So if the rear index is max -1, I can safely say that my queue is full. So I repeat, if the value of rear is max -1, so we can say our queue is full. This is a linear queue. So our queue is full if the rear is max -1. So for if full function, the condition is rear, a queue of rear double equals max -1. So if this is the case, if this is true, then we will return 1, means the queue is full. If this is not true, if this is false, then we would return 0, means the queue is not full. Likewise, for isEmpty function, the condition is any index you can compare. Q of rear equals -1 or Q of front equals -1. If any of the indices, if any of the variable is -1, it means that your queue is empty. So if this condition is true, we'll return 1, indicating that the queue is empty. Else we will return 0, indicating that the queue is not empty. Next is the insert function. Now, if you see here carefully, so I'm not coding it from sketch, because that we have done in stack, and I hope that once it has been done for stack, then you understand that how that has been done. So I need not have to do it again and again. Okay. So here is the insert function. So in the insert function, what you can see that the prototype, or I can say the signature of the function is same to the signature of the push function. Okay. For push, we passed two elements. First was the address of a stack. Second was the element to be pushed. Exactly in the same way, for insert in a queue, we'll be passing two arguments. First, the address of a queue in which the element is to be inserted, and second is the element to be inserted. Okay. So the first is the address, second is the element itself. Now first is the address. So here in the function, we need to have a pointer to accept that address. So that's why we have structure queue star queue. Okay. Second is the element. And since we are storing an integer type of element into our queue, that's why the second argument becomes a argument of integer type. Okay. If the insertion is done successfully, we would return true from this function. If the insertion is not done because of any reason, we would return false. Okay. So we can return 1 if the insertion is successfully done, or we will return 0 if the insertion is not successfully done. Okay. So the return type becomes int. Before the insertion, you need to check whether the queue is full or not. If the queue is full, you cannot perform the insertion. If the queue is not full, then only you can perform the insertion, just like your stack. So we are calling the isFull function. If is full, we are passing the pointer queue. Okay. If this is full, if this returns a true value, that is 1, so we will simply return 0 from this function. It means that your queue is full and we cannot insert anything into the queue. If this is not the case, if return 0 अगर ये condition false है, so we'll definitely come at this point. When we come at this point, what we are doing, see here carefully, this is pre-increment. So first we are incrementing the value of var by 1, and now at this new value of var we are inserting a given element. Okay. So queue of data, this is my array, queue of data. Okay. Into this array, add this new value of queue of var. So first, whatever is the value of queue of var, that would be incremented by 1. This is the pre-increment operator. And then at that index value, this given element would be stored. The given element D would be stored into a new value, a new index value, which is provided by queue of var into our array data. Okay. Then this is additional as compared to your stack, because here you have two variables, var and front, both. So if queue of front equals -1, queue of front equals 0. Can someone tell me what is this? Why I need to have this? If queue of front equals -1, then I am saying queue of front equals to 0. What is this? This is when you are going to have the first insertion. When you are inserting an element for the first time in the queue, your queue is empty. When your queue is empty, your var and front both are -1. Okay. So when you come inside this function, is full, this is false because the queue is empty. You come at this point and then plus var. So now queue of var was -1. When we write plus queue of var, it becomes 0. Okay. Then queue of data of 0 equals to D. The given element would be inserted or would be copied at the 0th index of our array. Okay. Now we are putting this statement because this is the first insertion. And whenever you have first insertion, the value of var, यहाँ पर plus हो गई, the value of var has been incremented by 1, so it has become 0. But your front is still -1. Your front is still -1. Now that front should point to this first element. The first element is at index value 0, and that's why we are checking that if queue of front equals -1, queue of front should be 0. So basically, this is a check for first insertion. Check for first insertion. If this is my first insertion into a queue, then I would be making my front variable as 0. It is as simple as that. If this is going to be the first insertion in my queue, then queue of front should be set to 0. That's why we are writing queue of front equals to 0, and then we are saying that the insertion is done successfully, so we are returning 1. Okay. So we stop today here. Can you please repeat, sir? Okay. This part, queue of front equals to -1. What I am saying that when you are inserting an element for the first time in the queue, your queue is empty. When your queue is empty, both the variables var and front are having a value of -1. Why? Because we have initialized the queue as front and var both equals to -1. we have set both the variables as -1. Okay, so both variables are -1. Now when you are inserting for the first time into the queue, when you are inserting an element for the first time into a queue, both the variables are -1. So now when you come at this statement, this plus plus q of rar, the pre-increment operator, this will make the value of q of rar as 0 from -1. -1 को अगर आपने plus plus किया, so it would become 0. ठीक है? So the rar has become 0, and into that index position you have inserted the first element. Now the first element has been inserted, so your front variable should also point to that first element. Okay, and since this is the first insertion, the value of front is -1. So that's why we are checking if q of front is -1. So this is my first insertion. The element has been inserted and it is at the index value 0. So the front variable should have a value 0 so that it will start pointing to that element. Okay, that's why we are writing q of front equals to 0. And this is conditional. Why? Because only for the first insertion I need to do this. For the second insertion, when the second insertion is done, rar will be incremented by 1. So rar will become 1 from 0. And at the one index value, one new element would be inserted. But your front is still 0 because it is pointing to the first element. So the value of front is 0, index value is 0, that is pointing to the first element. Okay. So this we are doing only for the first time or for the first insertion. So if my q of front is -1, double equals -1, then only I am going to set it as 0. So q of front equals to 0. Is that clear now? Okay, thank you. So we'll stop today's discussion over here. And if you have any query, then you can put up your query into the chat box, or you can unmute your mic and you can ask. Now, this recording is going to be saved in Khan Farhan's Google Drive. So I am